All right, pre-algebra people. Today we are jumping into bases of 10, or the powers of 10, and we're going to understand some tricks for multiplying and dividing tens, which might be intuitive for some people. You might already know some of that. And we're going to represent multiples of 10 with an exponent or a power. And we're also going to represent some powers of 10 with a decimal point, and reverse that process. This is going to serve as a little bit of a prelude to scientific notation, which will jump in a Khan Academy investigation after this. So the first thing I want you to do is just simply pause the video and go to the next slide and see if you multiply or divide these without a calculator. And I think some of them are going to be easier than others, but some of them might actually make you think. So the first one, 2 times 10 is obviously 20. Go ahead, pause the video, and I'll do the same and see if we come up with the same. Okay, and let's walk through them one by one. We said 2 times 10 is 20. That should be not new news to most people in this class. Negative 8 times 10 is negative 80. Okay, a negative times a positive is a negative, of course. 2.5 times 10, or 2.5 times 10, is 25. Okay, that's a 10, and then a half of a 10, which is 25. 7.14, now we're talking about decimal. 7.14 times 10 is 71.4. You might have had to do some longhand multiplication on that if you didn't know some of these tricks for multiplying by tens. 50 divided by 10, 50 cut 10 ways is positive 5. 620 divided by 10 is 62. And 5.3 divided by 10 is 0.53. So $5.30, if you think about this in money, divided 10 ways is 53 cents. A negative 7 cut 10 ways. Negative 7, negative divided by a positive is a negative, and it's going to be negative 0.7. 0.18, if you had 18 cents cut 10 ways divided by 10, is 0.018. A little less than 2 pennies, 0.018. So what I want you to stop on the next slide, stop and reflect. Okay, if these are your answers, what are some of the tricks for multiplying by 10? Let me see. I guess the first 1, 2, 3, 4, 5 were all multiplying ones, and the second 5 were all dividing ones. Okay, so what are some of the tricks for multiplying by 10 that you saw, the ways that you think about doing it mentally, and what are some of the tricks for dividing by 10? Go ahead, pause the video and reflect, and let's see if we have similar conclusions. Okay, so when you're multiplying by 10, hopefully you came up with something. Let me get my selector out. Select. Something like this, where we're moving the decimal place once to the right, or adding a 0. For example, 5 times 10 ended up with 50, which is the number 5, the first factor, which is another 0 added onto it, or another place value added on. And 6.23, $6.23 times 10 became 62.3, $62.30, moving that decimal place once to the right, okay, which is the same thing as adding another significant place value. Now, dividing by 10, since dividing is the inverse of multiplying, the reverse process happens. You move the decimal once to the left, or take off of a 0. For example, it's 500 divided by 10, $500 cut 10 ways is $50 for each person. 6.23 divided by 10 is going to have to move that decimal once to the left, which would be 0.623. Or the more official way of saying that would be 623 thousandths is the proper way of saying that decimal. The proper way of doing that, okay? Let's move on to the next slide. So this should be a little bit of a review from this unit, how to represent things with an exponent. It says write each multiplication problem with an exponent and then find its answer. So I'm going to go ahead and you can do this along with me. But 10 times 10 is represented with an exponent. I have 2 factors of 10. So 10 times 10 is stretched out. That's 10 to the first power times 10 to the first power using the product rule. That becomes 10 to the second power, which is, hopefully everyone knows, is 100. 10 times 10 times 10, that's 3 factors of 10, so that's 10 to the third power. And 10 to the third power is 100 times 10, which is 1,000. Maybe you're seeing any kind of pattern between the original problem and the final answer. The original problem and the final answer. And 10 times 10 times 10 times 10 is 10 to the 1, 2, 3, 4 tens there. So it's 10 to the fourth power. And then that's 10,000. That's 1,000 times 10, or 10,000. And let's see, are there any possible patterns that you're picking up here? Okay, 10 squared is 100. 10 to the third is 1,000. 10 to the fourth is 10,000. We're doing a lot of things with zeros. So hopefully you're picking up that 10 to the second power has 2 zeros. 10 to the third power has 3 zeros. 10 to the fourth power has 4 zeros. Okay? So what I want you to do right now is let's flip the paper over. Let's flip your note sheet over. Okay? And we're going to start by actually listing out all of the powers of tens down from, I think it goes from -7 to 8. But we're going to start right in the middle, and I'm going to do this alongside you guys. Okay? So right in the middle of the paper, let's start at 10 to the first power. 1 power of 10, what is that value? Okay, 1 power of 10 would just simply be 10. Anything to the first power is itself. Okay, let's go up the power chain. Okay, and just kind of recap what was said on the last slide. 10 to the second power is 100. If you notice, we have 2 zeros. 10 to the third power is 1,000. And we start adding commas. 10 to the fourth power is 10,000. 10 to the fifth power is 100,000. 10 to the sixth power, 1,000,000. 100,000, 6 zeros. 10 to the seventh power, 10 million. I'll actually write that, 10 million. And then 10 to the eighth power, which would be 100 million. 100 million. Okay, and then obviously it keeps on, it doesn't stop at 100 million. This is just all I had room for on this particular paper, right? The next digit everybody would know would be 1 billion, okay, which would be 1,000 million is 1 billion. So let's actually just write that in there for the fun of it on the top. 10 to the ninth power would be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1 billion. Also represented as 1B if you're in the financial sector. Okay? All right, so every single time that you drop a power of 10, you're dividing by 10. So 10 to the ninth divided by 10 is 10 to the eighth. So 1 billion divided by 10 is 100 million. Divide by 10 again is 10 million. Divide by 10, divide by 10, divide by 10. Every single time that you drop a power, you're dividing by a factor of 10. Okay, so how do you drop a power from 10 to the fifth to 10 to the fourth? Well, you're going to divide by 10 one time. Then you're going to divide by 10 another time to drop to 10 to the third. And then you drop by another power of 10 to drop down to 10 to the second. Okay, and then 100 divided by 10 is 10. So just to recap, I know we've talked about this in Unit 1, but what would 10 to the 0 power be? Okay, if I take 10 to the first and divide it by 10, it is not 0. 10 to the 0th power is 1. 10 to the 0th power is 1. And once again, how many zeros does the number 1 have in it? Well, it has 0. So hopefully you're picking up on that pattern there. Okay, now let's go down to the negative powers. Okay, so every single time that I had to drop a power, I was dividing by 10. Let's do that again. So what's going to happen when I divide 1 by 10? I divide 10 to the 0th power by 10. I'm going to change colors here for this. So if I divide 1 by 10, I have the problem 1 over 10. Well, that could be considered the fraction 1/10. That's absolutely fine. Okay, or that's also equal to 0.1. 1/10 It's also 10 cents. If you think about this in terms of money, you've got $1, $10, $100, $1,000, $10,000, up and up and up. But if you cut $1 10 ways, you're down at 10 cents. Okay? Negative exponents mean to divide. Negative exponents mean to divide. Okay, now let's take 1/10 and divide that by 10. Or another way of doing this is you are dividing by 1, 1 by 10 twice. You're dividing 1 by 10 twice. Where's my blue? Here we go. Which would be 1 over 100. It's 1/100th, which in terms of money, now we are at our smallest denomination of money here in the States. So 1 over 100 is 0.01, which in money value is 1 penny. Okay? And then let's keep going. Okay, hopefully maybe you're picking up on some patterns here. If I go 10 to the negative third power, go 10 to the negative third power, that's 1 over 1,000. I'm taking 1 and dividing it by not 1 factor of 10, not 2 factors of 10. I'm dividing it by 3 factors of 10. So I'm dividing it by 1,000. In this case, it's going to be 0.001. Okay? Which read appropriately, excuse me, it is 1/1000th. 1/1000th. Let's divide that by 10. Divide that by 10. Okay? If I divide that by 10, I have 1 over, the fraction is 1 over 10,000, which is 0.0001. Interesting. And hopefully you're picking up what I'm throwing down by now, and you're seeing some pattern here. So 10 to the negative fifth power is the number 1 divided by 5 factors of 10, which is dividing by 100,000, which is 0. We're getting closer and closer to just 0 flat. So 0.1, 2, 3, 4 more zeros. And that would be represented as 1/100,000th. Okay? And then this is 1 over 1 million. 10 to the negative 6s, of course. So we go 0.0000001. Okay? Interesting. And then this is 1 to the 1/10,000,000th in a fraction. We are dividing the number 1 up a whole lot of times. 0.0000001. Interesting. And there's also some great patterns going on here. So if 10 to the negative 7th, if you notice something about that, there are, first of all, how many zeros are there again? Let's count them. 1, 2, 3, 4, 5, 6, 7. And also, how many significant place values are there to the right of the decimal? How many significant? So there are 1, 2, 3, 4, 5, 6, 7 significant place values. So if you're picking up on that pattern, the same thing happens for 6. We've got 6 total zeros and 6 significant place values after the decimal point. Okay, and that pattern continues. And if you wanted to kind of, I have all of these dividing by 10s on the right-hand side. If you wanted to go over here and say that 10 to the negative 7, let's break out a different color, yep. 10 to the negative 7 times 10 is 10 to the negative 6, and then multiply that times 10 to generate 10 to the negative 5th, and then we'll multiply times 10 to go 10 to the negative 4th, and then times 10 is 10 to the negative 3rd, etc., all the way. You can keep on going all the way up until you get back to 1 billion, which is the top of our powers of 10 chart. All right, let's go back to the notes that we had there. Okay, now that we have that on the back, flip your paper back over. And it said, based on the patterns of 10 chart, let's write the standard number that each power would represent. Pause the video and go ahead and do that. So if you picked up the moral of the story from the power of 10's chart, 10 to the 10th power should have a 1 and then 10 zeros. It should have a 1 and then 10 zeros. Oh, my pen is not working. Why? Here we go. So I'm just going to have to type. I'm going to be adaptive because this program's not working the way it's supposed to. Or maybe it's not working at all. Maybe it's not working at all. No. Let's see if I could close it out and reopen it. Sorry about that. And we're back in business. So 10 to the 10th power should have, as was indicated before, 10 zeros. So you have 1 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go ahead and put our commas in every 3 significant place values. And that is read as 10 billion, right? So we didn't have that one on our chart in the back, but I think you picked up on the pattern. 10 to the 10th power will have 10 zeros in it. Now let's break out the product rule on this. What would be 10 to the third times another 10? So 10 to the third times one more 10 would be 10 to the fourth power, and that one is on our chart. That would be a 1 with 1, 2, 3, 4 zeros, which would be 10,000. Okay, what about 10 to the fifth? Well, let's just level that one up one more place value, one more zero, which would be 100,000. Okay, and then 10 to the negative 10th power. 10 to the negative 10th power. You could have done this a couple different ways. If you said, well, if 10 to the 10th power, is 10 billion, I'm just going to go cheat hack on this and go 1 over 10 billion. That's absolutely fine. If you wrote the fraction 1 over 10 billion, that is cool. But you might have also remembered that you're going to have 10 total zeros, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a 1 afterwards. And then you'll also have 10 significant place values after the decimal point. And one more time on the product rule here on this one, 10 to the negative 9th times 10 to the 11th power can be simplified using our product rule, which would be 10 to the, add the exponents, positive second power. And I know what 10 to the second power is 100. So 10 to the negative 9th power is some infinitely small, or some, not infinitely small, but some incredibly small number. And then 10 to the 11th power is some ridiculously huge number. When you multiply those, you end up with just simply 100. Okay? This is basically saying divide by 10 9 times. This is saying multiply by 10 11 times. And the multiplying factors win out with 2 factors. Okay, let's reverse that process. Last thing here. So based on the powers of 10 chart, use an exponent of 10 to represent each number. Interesting. So this is 10 to the what power? 10 to the what power? Interesting. Well, let's think about our patterns that we had going on. All right, how many factors or how many significant place values are after the decimal point? So to turn this into a 1, you'd have to multiply by 1, 2, 3, 4, 5, 6 factors of 10. So that means that this is going to be 10 to the not positive 6, but negative 6. See how many zeros there are. 1, 2, 3, 4, 5, 6 total zeros and 6 place values after the decimal point. This is 10 to the negative 6 power. So by that same exact logic, this should be 10 to the 1, 2, 3, but not positive 3. It is going to be negative 3. It is taking the number 1 and dividing it by 10 3 times. Good old 1 million here. You can just look it up on the back. 1 million is 10 to the 6th power. And if the decimal point is here, I would have to move it to turn it into 1. I would have to move it 1, 2, 3, 4, 5, 6 place values. It has 6 zeros on it. 100 has 2 zeros, so it is 10 to the 2nd power. The number 1 has 0 zeros, so it is 10 to the 0th power. And then 10 just by itself has 1 0, so it should be 10 to the 1st power. I think that should be enough to get you going on homework and also have a little bit of intuition in terms of scientific notation representing huge numbers and really, really small numbers as a power of a product of 10, which is where you're going soon. Have a nice day.